muggy air for us for this afternoon, but we'll have a lot of dry time overall in general. And again, feel free if you have any questions about the severe weather threat or the heat wave on the way, you can just plop them in the comments there and we'll get to them. All right, so as we look ahead here, let's go to 3 o'clock this afternoon. So this updates hourly. So this is the freshest high resolution weather model data that you can get. And we'll compare and contrast that the models haven't been perfect. I will always admit that. The HER and the NAM 3 kilometer, the two main high resolution weather models. We can look at the WRF weather model, the WRF as well. And again, we can compare and contrast all these. The timing might be just a little bit different, but in general, late afternoon at the earliest, but generally after around 6 p.m. is when it has been showing that threat of severe storms. So that's 3 p.m. There's 4 o'clock, and then here is 5 o'clock. So this is like about an hour earlier than I was seeing just about an hour ago. So that I'll go ahead and bring this up full screen. So this is some of the latest data showing those big storms bubbling up at that heat of the day right here at 4 to 5 o'clock. So this is at 5 o'clock actually. I'm just going to have to watch out for some of those supercells there that could be packing a punch with damaging wind gusts. Our main threat can't rule out though an isolated spin-up tornado. What happens is, and I can draw this, so this is a depiction of the storms later on today. You get a bow echo here. So it looks like the bow, like archery, you know, a bow. So you get these low-level jets that'll push out that rain in that bowing segment. So the apex right here of that bow is where a lot of times you'll get those damaging wind gusts in excess of 60, 70, maybe 80 miles per hour. But on the ends here, we call this a bookend vortice. And sometimes you can get like a little spin up EF0, EF1 tornado. So we're going to watch out for those bow echoes later on this evening and maybe a few tornado warnings as well. So always busy, it seems, this year. It's just been a crazy year of active weather. Now this is around 6 p.m., 7 o'clock, 8 o'clock rock there. So as we head toward sunset, this model has us seeing that severe weather threat diminish off there pretty rapidly. So overall, we're seeing 5, 6 p.m. heads up here in southern Indiana, a little bit later for Kentucky. So maybe it's kind of like a 5 to 9, 6 to 10 time frame for that highest severe weather threat. And again, this is just one weather model that we're looking at so far. Again, they update every hour. So you're looking at the freshest data at the exact same time I am. Fresh eyes on the fresh data. All right, let's get back to it. All right, so that's at 8 o'clock. And you can see the storms linger longer in Kentucky than Indiana. And then that's around 10 o'clock, that severe weather threat leaving. So we got a question here. What is a shelf cloud? So shelf cloud, it's very noticeable, leading edge of a thunderstorm that'll move through. It's attached to the thunderstorm. So it looks like a kind of a layer and kind of a foot out in front of a supercell, a line of storms. A lot of times you'll get a gust front out ahead of the parent thunderstorm. And so it's that leading edge that kind of looks smooth sometimes, has some striations every once in a while. It'll look like very dark and purple, maybe underneath, and then kind of smooth in the front. That's your shelf cloud. Now, a roll cloud is not attached. It'll likely be rolling ahead of the severe thunderstorm. It is not attached to the storm. It's kind of rolling along the gust front out ahead, that cool air that rushes out ahead of the thunderstorm, and kind of looks like a roll, just a roll. So you got a roll cloud that's sometimes possible with severe storms or lines of severe storms. And then you got the shelf cloud that's on the leading edge of the supercell as well. And then you might have cumulus congestus, which is a scud cloud, or we call SLC cloud, scary looking cloud. Sometimes they're very low near a thunderstorm, and they can get so low they kind of look like a tornado, kind of a mock tornado. You get a wall cloud that's underneath the updraft of a severe thunderstorm. That wall cloud is where a lot of times a nearby tornado could form. So you're always kind of looking out for those lowerings. But typically, if a storm's doing that stuff, it may have a warning anyway. And so you just want to be inside, not checking it out. And we've got hello from Laura DeVore. Thanks for watching. JK's, hello to you. Wyatt Wright, thanks for tuning in here this morning. And Lillian Lasley there from Grayson County. Thanks for watching here this morning. And my mom was just showing me a picture of the tree limb from her that was inside of her attic from the March storm that rolled through there. And I forget what day it was, but I was doing tracking live severe weather from her basement. I don't know, a month ago, sometime in May. And then 3 trees fell in her backyard live. Had to cut all those up. So hopefully my mom's house will dodge the storms here in June. Crazy stuff. All right, let's get back to it. So that's the HRRR weather model. Let's go to the NAM 3-kilometer weather model, and we're going to need to back up the data to right now or near right now. It's been a little more ambitious with these morning showers. There's not much rain out there. So this is at 11 o'clock, but there might be a passing shower. And Sarah says, good morning, Ben. Will you be showing a different weather model? We are showing a different weather right now, as you commented. So this is the NAM 3-kilometer weather model. We'll take this into the afternoon as well. Again, maybe a passing shower moving off to the northeast. Majority of the afternoon dry. It has not been as organized with that severe weather threat during the late afternoon. And it's a little bit later as well. So this is around 7 to 8 o'clock. It has it moving in several hours later than the HRRR weather model. Both of them have been kind of consistent in their individual messaging. So this is around 8 to 9 o'clock. And then has the storms moving in and lasting later in the night. This is at 1 a.m. Now, myself, I kind of lean more towards the HRRR weather model right now, bringing it in before sunset or right around sunset. Either way, this evening, heads up on that severe weather threat. So that is the NAM 3-kilometer weather model showing the active weather, the heavy rainfall, maybe some localized flash flooding, frequent cloud-to-ground lightning. Some areas might pick up a good inch of rainfall out of this as it moves through. And there you can see the rain continuing through the late night hours is at 4 a.m. We'll take this to tomorrow morning. And again, this is going to be a slow-moving front, so we could keep a few showers around tomorrow morning. This here is at 8 o'clock tomorrow morning. Still, you can see a little bit of activity across the area. No severe weather for tomorrow. As we go into the afternoon, looking at still a chance for a spotty shower, maybe a rumble of thunder. So this is around 3, 4 o'clock tomorrow with, again, the NAM 3-kilometer weather model. So that's tomorrow afternoon. So we're not totally out of the woods as far as rain chances until Friday. Friday is when we start to see a better chance. Well, no, I wouldn't say a better chance, but dry weather pattern, a dry weather pattern on the way starting Friday through the weekend through much of next week. And that will transition to that part of the weather story here in just a second once we get through that severe weather threat for today. I do want to bring up one more weather model. This is the high resolution WRF weather model. This is starting off tomorrow. Let me back this up to now. You see all of them are a little bit different. They're starting off, some are a little bit wetter when they dry off. The mathematics are a little bit different on all of them. They ingest the data a little bit different. All of them, though, have showed a mainly dry afternoon through late afternoon. So this is through 2 p.m. So the WRF weather model, pretty similar to the HRRR weather model. So we've got 2 high-resolution weather models, the WRF, the HRRR, saying maybe initialization of the severe weather threat or the development of the severe weather threat late afternoon. So maybe around 5, 6 o'clock. So this is the WRF weather model at 5 p.m. Again, we're all looking at this fresh because the data is just coming in. So there you go. That's kind of one of the earlier ones, around 5 o'clock-ish for the beginning of it. And then this is heading towards sunset. So both of the weather models, the HRRR and the NAM 3 kilometers, showed the potential of storms by late afternoon after 5 or 6 o'clock and then diminishing after sunset. And as after sunset, that would make sense as we lose that daytime heating. The storm's not expected to be as powerful, more disorganized after sunset, but still some scattered showers around along and ahead of the front that still has not moved through during the overnight hours and early tomorrow morning. So this is at 1 o'clock in the morning. Again, this is the WRF weather model. A lot of times we'll just look at the HER or the NAM 3 kilometer. We're adding in a third high resolution weather model here. So this is going into tomorrow morning. It also shows a few showers around 7, 8 o'clock, as we still don't have that front moving through the area just yet. And then this is at 1 o'clock tomorrow, just like the NAM 3 kilometer, showing that chance of some leftover spotty showers for our Thursday morning and Thursday afternoon. I've got it at about a 30 or 40% chance of a shower tomorrow. So we're looking ahead. If you're just popping on, yeah, the main focus here for today for our Ben at 10 show is the severe weather threat for this evening. But we've looked at that with 3 different weather models. Now we're kind of looking ahead to tomorrow, and then we're going to look ahead to the heat wave that we have on the way. Got a question popping in. Good morning. A little bit late. I'm here. Thanks for your update. Jump in the puddles and have fun. Always looking at the positivity and always loving the emojis there. Laura, which model do you consider the most accurate? Neither, because sometimes one does better than the other. You'll look at congruency. When they agree, you're like, okay, these two are really picking up a lot better on the situation than these. You look at the initialization. How are they picking up the current situation? If a model is picking up on the current situation better than another, for whatever reason, you can go back to chaos theory, the butterfly wings that make a little ripple in the atmosphere and then change the weather on a different side of the world. So these weather models are fascinating in how and their mathematics and how they pick up everything. So if one weather model is doing better at the beginning, high likelihood it'll do better later on. So the physics and all of that goes into the weather models is incredible. We've got 2 out of the 3 weather models that are the high resolution ones that only go out, maybe like 24 hours or so, that are saying late afternoon, early evening start time for that severe weather threat. The NAM 3 kilometers, the outlier that had it a lot later. So kind of throwing that one out now. Either way, we all just want to be extra weather aware, have that family plan ready to go, know where to go, what to do, have that first aid kit, maybe the pillows and blankets, just in case. Most of us are not going to get that tornado warning, but if it happens in your area, we always want you to be prepared and be as safe as possible. And then, so the difference here, your tornado warning could be radar indicated. We see the rotation on the radar, or it's confirmed. And that'll have a different color on the polygon or the warning shape when it pops up on the radar. Typically, it's like a purple if it's confirmed tornado and doing damage on the ground. Radar indicated, typically red. Severe thunderstorm warning. The definition here from the National Weather Service is above around 60 miles per hour wind gusts. That's when you start to get tree, power line damage. So 60 mile per hour plus is when we get a severe thunderstorm warning. We see that with the velocity data. We're looking at the speed of the raindrops with those live radar scans. And then also you can get a severe thunderstorm warning if we are expecting hail 1 inch or greater. That can do damage, obviously, to roofs of cars and homes. So those are the 2 reasons, the criteria to get a severe thunderstorm warning above 60 mile per hour or 1 inch or greater hail. And then another warning that we might end up getting in a few areas is a flash flood warning. And that, of course, is because of too much rain over too little of time. Laura saying, I do not like the wind. Wind comes, I go to the basement. Hey, that's a good rule of thumb there for you. Let's now talk about the heat wave. And before I get into the heat wave, one last thing here, because we talked about the Storm Prediction Center. They are a division of the National Weather Service. Their one big job is to look across the country and see where severe weather might happen out of Norman, Oklahoma. So our area today is under a level 3 out of 5. That is the orange area there. It kind of looks like an avocado. All of Indiana, Metro Louisville, Western Kentucky under level 3 out of 5. That's called an enhanced risk of severe storms. And then east of I-65 and toward Lexington and Elizabethtown right now under a slight risk. That's level 2 out of 5. The reason being, you get farther east of I-65, you're getting a little bit later into the evening, say around sunset or later, we start to lose the heat of the day, so the storms might not be as strong. But as they hit earlier in the afternoon, just out west of us, all that orange area, you're feeding on some really warm and moist air across the area. So, and some stronger winds as well. That's another big ingredient for that out there. Let me go ahead and bring up the weather models one last time. Well, actually, we're going to look ahead, well ahead with the weather models here in just a second. But in the short term here for today, we can bring up the CAPE, the convective available potential energy around the area. And there's going to be a lot of it. So there's a look at the CAPE. Let me see what weather model we're digging into here. Let's go to the high resolution rapid refresh weather model. All right, so this is a look at the CAPE. We're going to go into this afternoon, and it's screaming. Okay, so 3,000 joules per kilogram, basically about as high as it gets as far as storm fuel for this afternoon. You're going to feel it. When you step outside, it's a wall of mugginess out there. So we've got plenty of energy for those storms as they head our way late this afternoon, evening. As always, I hope we do a storm dodge and we miss it. But if we've got the ingredients there, we've got to give you a heads up.